aspects. Uh, we will be moving over to database programming, database design and construction after this session. So let us start this session on software programming. And today we will discuss about different kinds of software programming. Where we learn about the concepts of how to create methods and how variables, constructors, and programming constructs are used. And we also learn about classes and objects. So using these concepts, we can build software products. So we will learn some aspects about web-based programming, database programming, and then we will learn about refactoring and debugging, etc. Most software products are being created nowadays are web-based. One characteristic of World Wide Web Network, Internet, is that it uses HTTP, that is for Hypertext Transfer Protocol for transmission of data. HTTP is a stateless protocol. Once a piece of data is transmitted, then the connection between the source and destination of data is terminated. After connection termination, there is no information saved anywhere about the data which was transferred. So, um, if you are building a web-based product, then you need to consider this aspect that suppose you are creating a website and a user using his web browser wants to connect to your website. So he may visit by using the URL of your website, and he will see any web page of your website, and the web page may be interactive, so user can put some information, can do some input on this web page, and then the user will send this information to your website. So the website will receive this data and may do some processing, like some database manipulation, and that work will be done. And at the same time, the connection with the user is reset. Like the user will be moved to a next web page, like maybe the response for what input he provided. So once the user navigates from the first web page, then there is no link remains between the user and the website. So if you want to keep the user information in with the website, it is not possible with simple ways. Like there is no connection, so there is no data about the user available on the website. Only thing is some data manipulation in the database may have been done, but now the website does not know about the user. So it is a big challenge, because what happens is how the website will know which user, what is the name, say name of the user, and what are his preferences. So the website does not know these things, and subsequently these cannot be set. Like if you wanted to show a page to the user, like the preferences the user has set, like the user wanted to see some data about his say the website is a shopping website for books, and the user has shown what kind of books he likes to browse. So this information is not available with the website. So how to solve this problem? So there are some ways. Let us see how to do this thing. For a website and a user connected to this website through internet, Once a web page has transmitted its data, the connection between the website and the user computer terminates. Now, when a new web page is presented to the user, no information about the previous web page exists anymore. Suppose the user has logged in into a website successfully after user validation. Now, if the user navigates to a new page of the website, then this login information will be lost. The user will no longer be able to access features of the website which are available only to users who are logged in the website. To solve this problem, session objects are used in web-based software products. So we use session objects with the web-based software products. Session objects keep data about a user, and using this data, the user is provided with a continuous login functionality so that the user can browse the website without worrying about losing his or her login information. So this is how we tackle this problem. Like we can have session objects which will keep information about a user, so that the user will be able to do things on the website, like in this case we discussed the login functionality. So once the user successfully logins in a website, then the user information, the website should know this user has logged in, and the information relevant to the user should be shown. Like, say for example, this website is about bank access system, and the bank has this login page, and the user logins in the website successfully. Then the next web page should show something like his account balance and some other functionality which are relevant only to this user. So it is only possible when you have a continuous connection with the website. So the session objects use uh, keep information about the user, and so that the user can navigate in the website, and still he will the information about the user can be maintained. So here is one example. So what we are doing in the program, we do import of some packages which the programming language keeps, like these are already defined for doing web-based programming. So generally it is one package could be http dot some packages, some classes which help in creating session objects, and then some utilities packages may be there which can do some further work for the programmer. So we first import these packages, and then we are creating a class. So we named it session manage, and it will extend http session. This http session uh, is a class defined in the package http dot something. So here in this class there will be some get and set methods to request and response parameters to keep information about the request and response information about a user, which are kept inside the session object. So then we define a method do get, and we are using this parameter request, which will be of HTTP session request. So it is again defined in the package HTTP dot something, and then the response. So session response. So again it will be of HTTP session response type, and then we will create some variables and keep information about the user. So First of all, a session is created. One variable session of HTTP session type, and we will keep information about this request object. So request.get session, and it should be true, so that the session will keep information about the user. Then we can set the web page title. So we are using variable page underscore title of a string type, and we will keep information something like welcome, you are back to this website. And then one variable visit counter. So we can keep a count of the number of visitors, etc. Like at any time, say 15 visitors are there. So and then one more person joins. So the counter should increase by one. So it is of integer type count underscore visit. Then we can create a key. So the key will keep information about each of the visits. Then user ID we can create for each specific user, and user ID key, so that we can keep information about these and store in session object. And if a new person arrives on a web page, then we can set some more things. So if session dot is new, if the session object is finding it is created new, like if the visitor visits web page for the first time, then we can set the title variable welcome, thanks for your visit to this website. So for other users who visited this website previously, then the message title will be different, uh, like we had shown earlier. But if a visitor is new, so it will be a different salutation. And then we can set of the session object attribute attributes of a session object using session dot set attribute, and we can pass information about the user ID and user ID key for this new user. And if user is not new, so we can keep the visits counts to be displayed on the web page. So we can display the visit numbers, the the okay, sorry, I got disconnected again. I'm correct connecting. So we saw this how we create programs for web-based software products. In the example of use of session objects provided, you can see session objects in action in all programming languages which can be used for building web-based software products. Packages are defined which are responsible for creating and managing session objects. You can import these packages to write your code for creating and managing session objects. In the above example, when the web page is refreshed, the session objects help in updating the web page visit count. For example, in this the web page we created, the program we created for a web page. If you refresh the web page, the counter will show increase by one, the number of counts for visits to this web page. So this is how you can create session objects and keep data of users. Like here, the counter increases because the in the session objects it can keep information about the previous session, and now since the when the page was refreshed, so there is one more increase in the visit to the web page. So that is why the counter will increase by one. So that means the now the website knows that knows the previous information and the new information about number of visits. Now we move to database programming. So the business logic does require computation when a user invokes some event. The business logic may need to access a connected database if it requires to view, create, modify, or delete permanent data which resides in the database. Database programming deals with the part of business logic which get connected to a database and does computations which deal with the database. The computations involved in database programming may be done to view, create, modify, or delete data in the database. Most programming languages provide libraries which help in doing the tasks of database connection and database manipulation activities. So, um, for doing uh, database activities, database operations, we need to make sure some things have to be prepared before we actually do database programming. So some things are like you should you should be able to connect to a database, and then some database uh, entity should already be created in the database, like the schema, table name, columns, etc. And then from the programming side, you should be able to connect to the database with some username and password, and then the programming language should be able to understand that you will be doing some database programming using SQL. So SQL language is structured query language which is used to do database programming. So it is different from a programming language like Java. So you can embed the SQL commands inside the Java language so that you will be able to perform database operations. So you need to manage all these things, only then you will be able to do some computer programming, database programming. So here is one example. So in most programming languages, the package which is named SQL contains the database connection task, and then database management task, and then the queries, embedding of SQL queries in the programming language, etc. So first of all, you need to import this package, and then you can create a class. So we can create a class like database underscore insert, and there we can define in this class some strings like the database driver name. So here the driver name is com.mysql.jdbc.driver. So these driver names are standard defined by the database engine creators. Like in case of MySQL, MySQL is a database created by some people, and they have created this driver. So they call it mysql.jdbc.driver. You need to define that. Then URL, database URL, you need to define like the database entities where they are located. Like in this example, it is located at jdbc.mysql, and then localhost slash database underscore name. So the schema for the database is located at this place, and how to connect to this database. So some username and password. you can enter, and then you can do the actual task of database manipulation. So in this method, so we can have a method, main method, and there we will first of all reset the database connection if it is, if some connection is already there. So we make it null, and then again some, if you have some query, so again and where you store this query, so again you make that string null, and then after that you define the driver name, database driver name, and then connection, so so that you will be able to connect. And then the statement, what data SQL query statement you want to do. So you can define the SQL query. So here we are doing writing insert into table name, and then values. Some values we want to insert in this table, and then this statement, SQL query statement you want to execute. And if this statement is not null, means that means it has it if some query is successful, means the in the get underscore statement some statement has been done in the insert, then you want to close the database connection. In the example given above, you can see how database programming is done. You need to import packages, libraries which help in database programming. You need to create a database connection using a connection string. This string specifies name and location of the database as well as authentication information, username, password. Once connection with the database get established, then you can do database programming. In the example, an insert statement is used which will insert or create a record in the database. Once the database operation is complete, then the database connection needs to be terminated. So this was all about this database programming. Now we will move to the model view controller architecture. We discussed this model view controller or MVC architecture in lecture 6, where we discussed the user interface design. So how those architectures, MVC architecture are programmed. So here we have one example. So in this example, we have four classes. One is user class, and there we define two methods, main and menu db methods. And then we have a view class where we define menu details method. Then we have a controller class. So there we are creating an object menu, object model of menu type, and then we have an object view of menu view type. And so these two basically view and model. So actually this model will be controlled by the controller uh, through this object which we create. Again the view will be uh, controlled by the controller using this view menu view object. And then we have a menu controller method. So there we can define some operations, and then we can have some accessor and setter methods. So there we can set and get information which is stored in the model. So one set method is set model name, then get model name, then set model menu number, get model menu number. So these methods, the set and get methods, can be used to control or to do some processing of the data which the controller gets from the model, and then the model can The control can update the view based on this processing, and then it can send this view to the view, and the user can see this see this view on its browser or user interface. And then we have a model class. So in the model class, we defined two variables, class variables. One is menu number, menu num, and menu name. So when these two variables can be get and set using the getter and setter methods. So we define these methods. So once we have this processing in the model, so these information can be get by the controller. Then controller processes the information which it gets from the control from the model, and then it updates a view. For example, suppose some new menu is created using this menu number and menu name. You create a new menu number and menu name, and these the getter setter methods are there. Using those, what the controller will do, controller will get this new menu number and menu name. It will read that read and set those values, and then it can update the view using this update view method. So this new menu number and menu name now will be available and can be sent to the view, and uh, view can be seen by the user. And in the user class, we have defined two methods, main and menu db. So if the user clicks the main method, if there is a button and this method is attached to that button, so user will get the view which was composed by the controller, and it will be shown. And if the user has clicked a button which is linked to menu db, in that case the user will get a view which is not created by the controller. It will be created, means some you can write a method where you directly do some processing, get the data which is processed in the model. So directly you can see that processing uh, here when this method menu db is the button which is linked to this menu db function method. So here we can show the difference of MVC as well as a model view. So the main method is linked to MVC architecture, and MenuDB is linked to a simple model view architecture, and there is no controller involved at all. Like here, the processing will be done directly. Whatever processing is done directly on the model is can be seen by the user. So we can show this architecture. This is a very simple architecture to understand how MVC works. In Chapter 6, Model View Controller or MVC architecture was discussed in detail. In MVC, a controller component controls the data flow in the software product. An example of MVC architecture is depicted in the above figure. There are four classes created: user, view, controller, and model. The model class is built using private class variables, menu name, and menu number. There are exception method also defined to get and set values of these private variables from other classes. The view class has a method which displays the menu name and menu number when called from another class. The controller class creates two objects, one each for model class and view class. There are exception methods defined which can get or set variables defined in the object which is created from the model class. There is also a method defined which will update the view. The user class has two methods, menu and menu_db. When the user invokes the menu method, then a view will be displayed to user which will come from the controller. When the user invokes the menu_db method, then a view will be created directly from the model. This view will not come from the controller. So this was all about MVC architecture. Now we will move to refactoring. On software projects which follow agile methodology, a complete software product design is not made before the source code is written. Instead, small increments of software products are developed in each iteration. Since there is no comprehensive software design in place, the source code written to create incremental addition in the software product results in software design getting cracked slowly. Some classes originally written may get extended to include new business logic. Some old classes may no longer fit to be used for developing new software features. In some other cases, a new interface need to be introduced so that the existing component structure may need to be changed. In many other cases, existing names for classes and methods may need to be changed to reflect their changed functionality. For changing design of an existing constructed software product, refactoring is used so that new product features can be added to the existing product features. Doing refactoring manually is very difficult. Classes and their methods are referenced at many places in the source code. Finding and changing all these instances manually during refactoring is time-taking and error-prone. There are many automated tools available which can be used to do all types of refactoring. Automated refactoring tools can be used to do refactoring without any errors, and at the same time, refactoring will be fast. So, refactoring is a very important activity on agile projects. As you know, the complete design for the software product being built is not available at any time because uh, initially you have a very small software product which is launched in the market, and project team uh, was building incremental software product features which will be added to the existing software product. So there will be many releases of the software product, and in each release some new software functions or features are added. So this clearly means there is no comprehensive software design in the beginning, because these increments means you are not planned in advance. These increments are decided after getting market feedback. Like some product, the marketing team works to find out uh, what are the user preferences and what the software features the users may want. So they give this feedback to the project team, and this then the project team builds the required software product features. So nothing is planned in advance, and thus we do not have a complete software design in hand at any given time. So what happens is when the new features are added to the software product, the project team creates some new classes or new components, software components, and integrate them with the existing software product or software component. And sometimes they may change uh, the existing software component to build additional software product feature. So In such a scenario, what happens is the software design may become weak due to these activities. Like for example, uh, software feature, product feature for say for menus, to creating menus. Uh, the project team had decided that there will be five main menus, and all the sub menus will come inside these main menus. Now they are finding that they have to define one more main menu. So since it was hard coded in the beginning to have only five main menus, so adding the sixth menu will be very difficult because it was already hard coded. So and now the project team will have to modify the source code to add this new menu. So they will have to rewrite to change the components, software components and classes. So it is a lot of work to do it. And similarly, suppose a new component is being added, and this component uh, has to integrate with some existing component, and this existing component does not have interfaces which can be used to integrate the new component with this existing component. So in that case, this existing component may need to be changed so that it some interface can be created which will allow the new component to be integrated with this existing component. So these kind of things keep going on. Similarly, sometimes a component is part of one package, and now it is realized that this component is better suited to be placed in some other package. So it has to be moved to this new package. So again, when this happens, you need to change a lot of code, and this code means the package name has to be changed, and so that the references of this component are intact wherever this component was referenced. Like the package name, it all those places has to be changed for this component. So similarly, sometimes you have created a component with a name, and now you realize that this name is not appropriate anymore. Like suppose you created a component called services. Sorry, say there was a bank online access system, and there was a component which was named say issue of new checkbooks. So the name of this component was related to some say checkbook or something. Now it is realized that the bank will be offering many services apart from this checkbook issue through this online access system. So the project team may have to include this checkbook facility inside services. So the now the top entity will be services. Inside that, one of the sub component will be check issue, and there will be some other issue services like creating a fixed deposit account, certificate of deposit account, or transfer of money to some other account, or just services, other any other services which the bank may be offering. So all of them will come inside this services main component. So that means you will have to rename. So earlier the services may have a name like checkbook. Now it has to be changed to services, and then sub components you need to create. So in that case, refactoring will be involved. So let us see some refactoring operations, how they are done. I will show you some code where you can do that. So suppose I have this package JDBC Aura, and it has this add class. And this add class, I realize that it is no longer uh, relevant to be kept inside this package, and in fact it will be better to keep the to put this class in some other package, like I have a package in here, this first package, right? So what I can do, I can do refactoring. Currently, if you see this this class, so the package name is JDBC Aura, and now when I move this package name has to be changed, because currently it is in this package. It will move to this package. So how I will do this refactoring? So what I will do is I will do the refactor, and I want to move right to. So I will move, and where I want to move. So I want to move this in this first package, right? So let me do it. Okay, so now this add class has been moved from JDBC or a package to first package, and the system has, you can see it is open here. The system has changed the package name as first. Now, earlier it was JDBC Aura. So if I had to do it manually, then I will have to go there and change it. But if you do it using an automated tool, these things will be done automatically. So wherever now this class was referenced, everywhere this package name will be changed, and the system will change everywhere. So that is the advantage of uh, advantage of using automated tools for refactoring, right? And then let us see refactoring for, say, you want to change the name. Okay, so new name, I am say I earlier it was child. Okay, so I am changing it to child one. So wherever this class was referenced, everywhere this name will be changed at all those places. So we will see, I guess in parent, this child class was referenced. So we will go and see if this change, this class name has been changed in this class or not. So the system is finding all the changes required, and it is doing the changes automatically. It is taking some time. I think we can escape it. It will do it, no problem. We can move to some other discussion. Let it do it. So now let us discuss debugging. When software source code is written, it may contain many errors. When a piece of source code is compiled, it may generate compilation errors when it is compiled. It is because of the errors present in the source code. Some of these errors may relate to programming syntax, and yet some other errors may relate to errors in business logic implementation. Business logic implementation errors are analyzed and corrected during unit testing, but programming syntax errors are analyzed and corrected during programming. This activity of analyzing and rectifying syntax errors is known as debugging. So we need to do a lot of debugging because by mistake we name some entities wrongly, or we did not use the syntax correctly, or the reference we provided was not accurate, like we wrongly uh, put wrong package name. So, due to those errors, when you try to compile your code, you will get compilation errors. So, to rectify these errors, you take help of the debuggers. They are automated debuggers, so they will show you the places where you have errors, and you can rectify, and you can mm, then rectify those pieces of code so that your code will compile successfully. So this is all about debugging. At the same time, you also may get some errors, or you may not even get some errors, which and but still your product has defects. So, for example, when you implemented your business logic, it was not implemented correctly. So, even though your code compiled successfully, like suppose you wanted to do calculation of interest on some bank deposit, but the formula for doing this interest calculation was wrong. So so that the calculated interest amount may come wrong, but your compiler will not create any compilation errors because your syntax was correct. So, but your business logic was wrong. So that thing we test in unit testing. So that is a different thing compared to debugging. So that is the difference in between unit testing and debugging. So when you and unit testing is done when you are doing testing. So unit testing we will discuss when we discuss testing activities. So this was all about programming aspects, and I guess you may have learned a lot of things in this session. So we will move to database design and construction. So we will discuss those things in my next lecture. So thanks for your time, and bye.